Problems caused by coding agents. As of early 2026, the shift from simple AI assistants to autonomous coding agents, like Claude Code, Devin, or OpenClaw, has introduced several systemic challenges. While they have dramatically increased development speed, they have also created a quality versus velocity friction point. Here are the primary problems currently resulting from coding agents. 1. The security debt and vulnerability explosion. Recent 2026 data shows that AI agents are speedrunning the creation of security flaws. Subtle logic flaws. Unlike obvious syntax errors, agents often introduce deep logical bugs, for example, bypassing middleware protections or improper password handling, that look like clean code. Dependency hallucinations. Agents may suggest or automatically install non-existent libraries. Attackers capitalize on this via slop squatting, registering those hallucinated names on registries like NPM to inject malicious code. The accidental insider threat. Because agents often operate with the same credentials as the developer, a compromised or confused agent can delete entire databases or leak environment variables without a single hacker ever entering the system. 2. Vibe coding and technical decay. The rise of vibe coding, where developers describe a feature and let the agent build the entire thing, is leading to architectural rot. Readability issues. AI-generated code is often found to be 3 times less readable than human code, frequently suffering from naming inconsistencies and verbose boilerplate that makes manual debugging a nightmare. Model mixing. When agents use different LLMs for different parts of a project, the result is often a jumbled mess that looks like 10 developers worked on it without talking to each other. Outdated patterns. Agents often fall back on deprecated libraries or pinned vulnerable versions, for example, using Tailwind v3 patterns for a v4 project, because their training data heavily outweighs the newest documentation. 3. Structural and economic impacts. The nature of the software engineering role is fundamentally shifting, creating new friction in the job market. Erosion of entry-level roles. Stepping stone jobs for junior developers are disappearing as agents take over routine tasks. This creates a talent gap, where there are no clear paths for juniors to gain the experience needed to become senior architects. Loss of system knowledge. Engineers report that delegating 80% of implementation to agents leads to passive monitoring. When an incident occurs, the human oversight team often lacks the deep, hands-on understanding of the system required to fix it quickly. Auditability gaps. Traditional version control, GIT, struggle to track the intent behind agentic changes. If an agent modifies 200 files in a single session, the human reviewer often lacks the context to know why specific architectural decisions were made. 4. Agentic interaction failures. Context compaction. Errors. As agents work on large projects, they may compact their memory to save space. In doing so, they sometimes forget critical safety instructions, like always ask for confirmation before deleting, leading to unintended destructive actions. Indirect prompt injection. Agents that browse the web or read external documentation can be hijacked by malicious instructions hidden in those documents, causing the agent to act against the owner's interests. Would you like me to generate a best practices guide for setting up secure sandboxes for these agents? Method: isolation level, startup speed, use case, micro VM, firecracker, highest hardware level, approximately 150 milliseconds. Unsupervised agents, Devin, OpenClaw, gvisor/Kata, high user space kernel, approximately 500 milliseconds, multi-tenant SaaS, enterprise CLI tools, Docker sandboxes, moderate, kernel isolated, 1 to 2 seconds, local development with human in the loop, Standard containers. Low. Shared kernel. Less than 1 second. Not recommended for untrusted AI code. To set up a secure sandbox for coding agents in 2026, you have to move beyond standard Docker containers. Because agents can now execute multi-step logic and install their own dependencies, a leaky sandbox is effectively a wide-open door to your host system. The current industry standard follows a micro VM plus zero trust architecture. 1. The Isolation Hierarchy, 2026 standards. The following table compares the isolation methods currently used to contain autonomous agents. Method. Isolation level. Startup speed. Use case. Micro VM. Firecracker. Highest hardware level. Approximately 150 milliseconds. Unsupervised agents. Devin, OpenClaw. gvisor/Kata. High user space kernel. Approximately 500 milliseconds. Multi-tenant SaaS. Enterprise CLI tools. Docker sandboxes. Moderate. Kernel isolated. 1 to 2 seconds. Local development with human in the loop. Standard containers. Low. Shared kernel. Less than 1 second. Not recommended for untrusted AI code. 2. Implementation best practices. To build a bulletproof environment, your configuration should include these 4 layers. Compute isolation, the room. Use a micro VM-based provider like E2B, Fly.io, or Northflank. These provide a fresh, ephemeral environment for every session that is destroyed immediately upon completion, preventing persistence, where an agent leaves a backdoor for later. Network egress filtering, the phone line. By default, the sandbox should have 0 outbound internet access. If the agent needs to install a package, use a proxy that only allow lists specific domains, for example, npmjs.com or pypi.org. This prevents the agent from exfiltrating your .env secrets to an attacker's server. Credential injection, the keys. Never mount your local ~/.ssh or ~/.aws folders into the sandbox. Instead, use short-lived scoped tokens. For example, give the agent a GitHub token that only has permission to write to one specific feature branch, rather than your entire organization. Human in the loop, HITL. Gates. For high-risk commands like rm-rf, chmod, or curl pipe bash, use a tool like bento run or augment intent. These intercept the command and require a physical approve click from you before the sandbox executes it. 3. Top sandboxing tools to use. Now, if you don't want to build this from scratch, these are the leading platforms in 2026. E2B, Essentials to Build. The gold standard for cloud-based agent sandboxes. It provides an SDK to launch secure Firecracker VMs instantly. Docker sandboxes. A new 2026 feature that allows agents like Claude Code to run Docker in Docker securely without touching your host daemon. Bento Run. An open-source MCP, Model Context Protocol server, that uses gvisor to run Python code securely for any agent. Do you know that any private information you put into a cloud AI is used to train that AI? A private AI running on your own hardware is the best way to keep your private data private. I can help you set up a private AI on almost any PC or server. Contact me for a free consultation. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. There are more than 400 previous blogs on my Patreon page, https://www.patreon.com/Steve Hovland.